Okay, so for Tuesday's homework, I know I'm doing it a little late. Sorry about that. But let's just move swiftly on to question 49. Log base c of a plus log base c of 1 over a. Um, so here, what we can first do is raise, not raise. You would raise this by this by you would raise this no you would use this to raise by c, if that makes sense. Oh, what did I just do? That's for a future problem. Why can't I delete it? Okay, so what does that mean? That means I put c on the bottom, or as the base, and I put this equation: log base c of a plus log base c of 1 over a, and it's all in parentheses. And then let's say this equals just some arbitrary x. Doesn't matter what it is. So this equals c to x, right? I just use this equation and I put c under it. That's all I did. Now this also equals c log c base c of a times c log base c of 1 over a equals c to x. And this is just how whenever there's an addition in the exponents, you can just split it like this. Um, this cancels. This cancels. So a times 1 over a equals c to the x. So 1 equals c to the x. And it doesn't matter what base of c there is, because the only x value that makes 1 is 0. So any value c x has to equal 0 to for the equation to equal 1. Hopefully that makes sense. I think this was a pretty easy problem, and I think part B is actually even easier. Recently we learned about sigma notation, and they kind of write out the sequence for us right here with PM to the W. So since that's the ratio, that is because it gave us the ratio, we just write that ratio down, and then we're summing it, so we obviously have to deal with the sigma notation. And obviously, since it starts with p, which is when m is 0, m to the 0, then we could just write any. It doesn't matter what. Oh, actually, let's erase w. Let's put n, and let's do n at 0, and then all the way to w to match out with this equation. So I think this equation is pretty simple. I don't think it's that hard if you're familiar with sigma notation. So on to the next question. Okay, now on to question 50. Now, when I was doing this problem earlier today, before I was doing the homework, I was very scared about showing this problem because I think it's one of the hardest problems to explain, and maybe that's just because I'm a bad teacher. But I would highly recommend, if I'm confusing at all, to just look it up. Um, but anyways, it's saying to draw the graph of x equals tan y. I'll do that real quick. Props to Desmos for helping me out here. It looks like this. And then explain why it's not the same as the graph of inverse tan of x. I think this is more, I'm going to explain this in a philosophical sense, or a logical sense, not really more of a, mathematical approach. Uh, Mathematicians, or somebody created y equals inverse tan of x because they want to achieve the specific angle at a ratio, if that makes sense. Because the initial equation is tan theta equals opposite over adjacent, and so inverse tan of theta, or inverse tan of opposite over adjacent, obviously equals theta. Now the problem with this is that this ratio, no matter how big the ratio is, will always be between -1 to 1. Or, I guess in this case, 0 to does not exist. Should be like this. And then dne to 2 pi, right? But like, it's has a limit, right? Because it doesn't matter how big the ratio is, it will always respond with a slope that's between, or an angle that's between 0 and 360. And now ignoring sometimes there's undefined angles and stuff like that because you're messing with like divided by 0, which is why I wrote dne, which does not exist. But for common sense, like, or for like simplicity's sake, it doesn't matter how big the ratio is of opposite over adjacent. It will always return an angle between 0 to 360 degrees. That's what inverse tan is. But when you actually do the inverse of tangent, now it doesn't matter what your ratio is. Theta will be proportional in size to your ratio. So I hope that makes sense. I know it doesn't really make sense. I would really look it up if my explanation didn't make sense. But you can also look at Desmos, right? My explanation's right. You would only, if you graph inverse tan, it would only show this line. But if you graph the tan y equals x, it would show all the other lines. But yeah, this is, and I'll summarize. The inverse tan is limited, right? You will only see the first, see a projection on the first cycle of a circle. But for this equation, it can just go on any cycle, so it can give you any angle, even if it's past 360. So I hope that makes sense. If it doesn't, please look it up. Okay, so on to problem 51. I remember doing this problem for the STEM book, for the STEM video, and I think it has a good explanation, but there's some added steps that I did not need to do. One of the main points is collinear, which means that if you draw a line between these external vertices, this would be a linear line, meaning that the slope is the same. So what does that mean? That means if I draw an angle theta here, I can draw another angle theta here, and I can draw another angle theta here, and they would all be the same. I'm also going to do some more add-on. This should be n minus y, right? Because if this is y, and that's n, that should just be n minus y. This should be y. This should be y minus m. And then this should be m. Now, why did I do that? Because we know these angles are the same, right? We know that tan theta equals here. It's n minus y over y. And we're using this triangle here because, right, opposite over adjacent. And then here, tan theta equals here. We can see this is y minus m over m. And let's just set them equal to each other, right? They're the same angle because it's collinear. So tan theta and tan theta should be the same. So n minus y over y equals y minus m over m. Here we cross multiply. mn minus ym equals y squared minus ym. If you add ym to both sides, they cancel. So you get mn equals y squared. And if you root both sides, you should get plus or minus square root of mn equals y. But because we're dealing with positively oriented, because it's size, there wouldn't be a minus. So it'd be square root of m times n equals y. And this should be your answer. Y in terms of m and n. Now, if you remember from a previous problem, I think it's 43 for this book, there was a problem on geometric mean. And you did... Oh, I forgot to write the... This right here is the same exact ratio that you used to solve that problem, and this is the formula for two-dimensional, or like a two-dimensional geometric sequence mean. So I think that's pretty cool that it connects to other problems. Okay, so on to question 52. It showed that 3 cosine 2x to be written in equivalent form y equals a sine mx plus b, therefore confirming that the cosine curve is sinusoidal. I think here the most important thing, if you're stuck and you're watching this problem watching this video to know how to do this problem, is just to remember that in degree mode, I'm gonna do this problem in degree mode. Cosine x also equals sine of x plus 90 degrees. And to make sure I'm right, cosine of 90 should be 0. 90 plus 90 is 180. Sine of 180 is 0. So yeah, okay, I'm right. Now this is important to remember because now we can rewrite the equation. X in this case is 2x. So this should show that cosine of 2x equals sine of 2x plus 90. And then 3 should just stay constant. 3 is not affected by x at all, or from the cosine to sine conversion. So, if we just multiply by 3, we just multiply by 3 both sides. So, that would be 3 cosine of 2 of x equals 3 sine 2 of x plus 90 degrees. And if you can graph this to make sure I'm right, if they want in radian mode, 90 degrees is equal to pi over 2 radians. So this should just answer 3 sine 2x plus pi over 2. And this is also an acceptable answer. So 52 is not that hard. You just got to remember this right here. From a previous problem. Not that hard. Hey guys, I know you're expecting problem 53 here in this spot, but I just wanted to let you know that when I was working through this problem and when I was trying to record this problem, it was really hard to get my ideas out to explain how I did the problem. For the last part of the problem, I think the first three parts of the problem are pretty simple. But when it's asking for the 100th term, I thought it was really hard for me to try to explain it in an easy way that other people can understand. So I would recommend to try your best just to do the problem. See what the teacher does, whatever teacher you have, to do that part of the problem. Since I'm not going to include problem 53 on this part of the video, I am going to mention how I was approaching to do it, so maybe you can come up with a way to do it. I assume that the probability at 99 will not change from the probability at, let's say, 2. So at like 2 iterations of this marble game, would it not be this? Would be the exact same probability as the 99th turn of the game. So the chance should just be the complement of the should be the same chance as getting a red marble on the second turn of the game. So that's my idea. You can work with that as you wish. But yeah, good luck. Hopefully I'm able to do the rest of the problems for the rest of the week. But this is the first time I got actually stumped.